Before we move forward on how to actually interpret the change in x for the actual probability of having y, I want to first go over just the basic assumptions of logistic regression, as well as how your computer is actually calculating that regression, and just briefly touch on some of the benefits of using logistic regression. So, which I think will become immediately apparent after we talk about the assumptions. So unlike OLS, we are not going to have to assume, right, that there's a linear relationship between that independent variable like age and the dependent variable like CHD. We know that's not going to be possible, right? And we don't have to assume that then the errors are normally distributed or that there's constant variance. Now, the thing that we are going to have to assume is that we have independent observations. So in this case, I think it's probably pretty safe to say that patients aren't influencing each other. But if we know that all of those individuals are coming from like the same neighborhood, and maybe, and I know this probably isn't the case, but maybe CHD is linked to some environmental factors or even socioeconomic factors, those observations may not necessarily be independent. So that is an assumption that we should look into. The second assumption that we have is that the independent variables are linear related to the logit transformation, right, of the probability of having CHD. Now, when you're actually running a GLM, or in this case, our specific GLM, a logit, what's going on in the background is actually that your computer is performing maximum likelihood estimation. Now, we are not going to get into this, but essentially what is happening when you're conducting MLE is that you are still trying to minimize the sum of the squared residuals. What's happening is that your computer is actually iteratively calculating the parameter that maximizes the log likelihood function of the sum of residual squares. Now, again, I don't want to harp on that too much, but I do think it's important that, one, you know what's going on in the background, and two, if you are interested, that's definitely a higher level course that you can take if you so desire. Now, last, why should you use the logistic regression? So, I mean, we've talked about a little bit of this, but the transformation of that probability of having CHD, the logit transformation of that, is actually quite nice, right? So we know that the probability of having that disease has to be bounded between 0 and 1, and we know that the odds, right, so the probability of having it over the probability of not having it is bounded between 0, right? Like, you can't have any lower odds than 0, and it can be infinite. So again, we know what the bounds are of the odds of having the disease. And moreover, we know that if we look at the log transformation of those odds, we now have a continuous outcome variable, essentially, that can go from negative to infinity to infinity. And this is a really nice property that we already had under OLS. So this response on the left is not bounded anymore between 0 and 1, even though the actual outcome themselves, if someone has the disease or doesn't have the disease, is bounded between 0 and 1. So the the response on the left can actually be any positive or negative quantity going from negative infinity to positive infinity, which is really nice. In the next video, we're going to talk about how to think about and interpret the odds of an event and odds ratios.